We're gonna jump in and we're gonna do some three-way switches. I've got a little PowerPoint that's gonna kind of explain kind of how the three-way switches work. These things can be a little bit complicated, but if you focus and pay attention to what I tell you right now, they're gonna be very easy for you to understand and to complete. After we get in today, I'm going to do diagram number 6 with you. So three-way switches, to kind of recap, I know I've mentioned this a couple times to you, but a three-way switch, the most common place that you're going to see these things is typically in a hallway in your house where you have 2 switches that are going to control 1 light. So if you have a hallway down your light, you might have one, at the end of your hallway where your bedrooms are at, and then on the opposite end, you're going to have another one. And all these things do is just allow you to turn on the switch. If it's like nighttime and you're like, hey, I'm going to bed, but it's dark, you turn on the switch in the hallway so that way you can see. And then when you get to the end of the hallway, you're able to turn those things off, okay? As opposed to a single pole. But this thing is wrong. I don't know why this title says single pole, single throw, because these switches are single pole, double throw. And I'll explain what that means in just a second. But anyway, 2 switches are going to control 1 set of lights. So they're a little bit different than just a standard switch that we've been wiring up in the diagrams, recently. Where it's just like a single switch that's going to do that. These things are still going to do the same stuff where you're going to basically break that circuit, or you're going to kind of close that circuit. So you're going to complete it or you're going to stop it. But how we do this is going to be a little bit different. For diagrams number 6, 7, and 8, they are going to be using three-way switches. So you're going to have 2 switches that are going to control 1 set of lights. The other 2 diagrams, 9 and 10, those ones you guys are going to kind of work on your own. You've got to kind of think a little bit critically with that, but you have enough information that you should be able to, especially after today, you should be able to complete all 10 diagrams. And that's what I'm going to want you guys to work on between here and the next week. Okay. Number 11 is an extra credit one. Okay. And you have to kind of use your head. You have most of the information to kind of figure that one out. Some of it you kind of have to, infer some things about. But I like to get students to think. I like to get them to use their head, and it's an extra credit. So if you do not want to do number 11, you do not have to do number 11. It's completely optional, but it is an extra credit. You do get an extra 10 points if you do complete that one and get it correct. But I don't help with that one, right? I want to make sure that you can kind of think and learn a little bit on your own. I will drop you a hint on that one, though. On number 11, it uses a 4-way switch, and it has 2 3-way switches in it as well. It is very similar in how you hook up these 3-way switches. So a little hint for number 11 is that is very similar to the same process that we're going to learn today. So you're going to kind of have enough information, and then just a little bit that you'll have to kind of, guess on or determine how those things work. But again, I want you to think a little bit. So a single pole, single throw switch, you can see these are the things that we've been wiring up right here. With these ones, they have 2 brass terminals. And essentially what this switch is doing is it's connecting those 2 brass terminals, or it's disconnecting those 2 brass terminals. Okay, really simple, really basic. Also has a little ground screw on there. On a 3-way switch, okay, it's going to have 2 brass. Notice there's one here and there's one on this side. And then it's also going to have a little black screw. Now, depending on the manufacturer, that black screw could be here. It could be on this side. They could put 2 brasses here and then the black one there. It doesn't matter where it's located. What's important is that you understand that this black screw is going to be kind of the key to hooking these things up. Okay, so there's 3 terminals that we're going to hook hot wires to. Okay, so a hot wire is going to go onto that black one. This one has a ground too. The grounds are the same. We've talked about that. I'm not going to beat a dead horse with that. You guys understand how to do that. The one thing with these 3-way switches is that typically on a switch, it says on and then off. On these ones, they do not have that because these are completely dependent on where the other switch is located, whether or not it's going to turn it on or off. So in your hallway, if you have a 3-way switch that's hooked up correctly, you might flip the switch up to turn the light off instead of flipping it down like you normally do on a single pole, single throw switch, like right here. Okay, those ones, it's always flip up or flip down. Unless somebody turned this upside down and installed it upside down, then it might be opposite. But does that make sense? Good with that? So that black terminal, okay, we are going to use the term common terminal. Okay, so that black screw is the common terminal. Okay, what that means is that that common or that black screw is always going to be connected to either that brass right here, or kind of where my fingers are at on the other side. There's the other brass screw, and it's going to be connected to that brass screw. So that common is always connected. Now that is different from a single pole, single throw switch where the two brass terminals are either connected or disconnected. Okay, that common terminal, that black screw, wherever that black screw is located, again, different manufacturers are going to put it in different spots, but it's always going to be a black screw. Okay, that one is your common. It also is going to tell you on the bottom of these things, I don't have a picture of it, but on the bottom of these things, it says common underneath that terminal there. And so if you read the back of it, it'll tell you which one it is. So this is kind of like a little bit of an illustration. You can see my little red line that I've got there. We've got that black screw, that's our common. And you'll notice with the switch flipped up in this position, it's going to be connected to that brass terminal. If I were to flip that switch down, you'll notice that red line kind of jumps across. And now this terminal is no longer connected, but now this terminal is connected. So essentially it's just bouncing back and forth, right? We flip it up, it goes to the top, to the left. We flip it down, it goes to the right, okay? So a little bit of the inner workings of these things. I'm a curious person. And so I like to know how things work. And so I've actually cut these things apart and I don't have them in here. They're in the shop right now. But, you know, kind of seeing how these things work. You don't really need to know how to do that. But if you're curious, you know, if you guys get a chance and you want to come by, obviously after this semester, once things come by, if you're a little nerd like me, then I can show you how these things work on the inside. Because I said, I'm just curious. I like to know how things work. And these things are fairly cheap, so I can kind of destroy them to just check them out. But essentially what's happening on the inside, what you really need to understand is that that black terminal, that common terminal right here, is always connected to either the brass on the left or the brass on the right, depending on how this switch is working. Do we understand that? I'm going to take the silence as a yes, or that I've already bored you guys and put you to sleep. Okay, so why that matters, okay? Because that thing is always connected, okay? And because each switch is going to allow power to flow into your light, okay? You have to know that those commons, okay, are going to allow for two separate paths, okay? So there's going to be a path for power to flow into here, and then a path for power to flow into there. Everything we've really dealt with thus far has all been just one circuit, right? You send the power out to something or into a switch and then to your light and then back. On this one, we're not going to have one path. We're going to end up actually having two different paths. Okay, and that's what allows us to like hook these things up. So here's some things that you want to make sure that you're paying attention to. And when you're diagramming these things, or if we were wiring these things up, these are some things that you want to make sure, you know, that we're aware of. Okay, so pay attention to these. Okay, the common terminals, that's the black screws. Okay, in your diagrams, it's going to have a C in the middle of it. That's going to tell you that it is the common. Okay, so if it's marked with a C, it is your common terminal. It is that black terminal that is on these switches. Okay, one common is going to go into your source. Okay, so that your source is going to be like your plug that you're plugging into, where you're getting your power from. Okay, the other is going to go into your light. Okay, so one common into your source, the other common into your light. Okay, they do not connect together. I've seen lots of students do that. Understand, they do not connect together. One common goes to your source, the other common goes to your load. Now, in this example here, well, we can do our neutral wires. That's neutral. So on this was my white. It's kind of screwed it up because that should be a black terminal right there. We know the neutrals, right? We know we need to get that neutral wire back into our source, so we can add those wire nuts in there, and we've got that stuff, right? That's not hard. That's not going to change on any of these diagrams. The tough things on any of this electrical is really figuring out where your hot wires go. Okay, so do that as normal. You can get your neutrals back. You can do that, so that way you don't have any issues. Now, the rule is 1 common goes to your source, 1 common goes to your load. What do you think I'm going to connect this common on this switch? Where should that common go? Where do you think?
Should it connect to the black one on the other one?
So this one, so you're saying this common should connect to here?
I'm thinking so, but I don't know.
All right. What does this say up top here? The common terminal. That's that black terminal that I'm pointing to, right? The common terminal is going to hook up to your source on one of them, and then your load, that's going to be your light, is going to hook up to your other common. These commons should never connect to each other. Okay, they should never connect to each other. So that common, okay, one of them needs to go to your load, and one of these two needs to go right here to your source. So this common on this first switch right here, where should we connect that common? It's not going to be to the other common. So where do you think we should connect it to?
The source?
The source. Why the source? Why not connect that common to our load?
It's closer to the source?
Don't make it sound like you don't have the right answer, because that is correct. Okay. The only reason we connect that common to the source is because it's a closer distance. I would have to take a wire, I'd have to go into here and then bounce it over to there. Okay, it wouldn't make sense. So if we follow the rule, 1 common goes to your source, where should this other common go on this switch?
Load.
What was that? Say that one more time.
Load.
To the load. And the load is our light, right? That's what's using the electricity. So we're going to connect the other common to the light. If you can remember that, and if you can get that down where 1 common goes to your source, the other common goes to your load, they never connect together. Okay, that is about 90% of the problems that people have when they're wiring these up. If you have one of these switches or these sets of switches in your house, and one switch has to be in one position for the other switch to work, there is an issue with your commons. Your commons are not going to your source and your load. If you replace these lights, or if you replace these switches and your stuff works fine, but you don't make note of what wire is coming in and connecting to that black terminal, and you rewire it up and you say, oh, I've got 2 black wires and a red wire, and you just kind of mix and match those things, it's going to change that order, and it's not going to work like it should. It's not a safety hazard. It's just not going to work like it should. And ideally, we want these things to work like it should. You don't want to walk across a dark hallway to then turn on a light, so that way you can see, right? That the whole purpose of these is so that way you can turn on and off the lights and get down, if you're in a dark room. So the only thing that's really left to do on here is connecting these brass terminals. And on these brass terminals, what we're going to do is we're just going to connect this brass terminal to the same brass terminal on the other switch. So we're going to connect it with there. I have another brass terminal I'm going to do the same thing with. The problem is, what color wire am I going to use with that? I've used a white wire. I've used a black wire. I can't repeat colors. So what color wire do you think I'm going to use for this?
Red.
A red wire. Okay, those 2 wires are called your traveler wires, that black and that red that runs between these switches. Those ones are going to connect to your brass terminals. Now, theoretically, it does not matter if I take this brass terminal and I connect it where that red one's at, and then I just connect these 2 straight across. This switch is going to work. It's not going to have any issues. For me, I just tell you connect that brass terminal to the same brass terminal to try to make it easier. But if you flip-flop those red and black wires right here and right here, it doesn't matter. It's going to work. I'm not going to deduct you points because it will work like it should. The ones that matter are the commons. 1 common to your source, the other common to your load, and just go to which one is closer. If they both are closer, then you have to pick one and then go to the other. So like if I had my light on the opposite side and my source were on one side and my switches were on one side, one switch is going to be closer to both the source and the load. Just make sure that only one common goes to the source and the other common goes to the load. I know I'm repeating that quite a bit, but that is really, really important for you guys to understand. And I've seen, like electricians, I've seen people that have messed this thing up, and you can do it very, very easily, okay? But if you keep that in mind and you just connect those ones first, okay, then the traveler wires, that red and the black, just connect the brass terminals, okay, to the other switch. That's all you got to do. Okay, so those red wires, I already told you that. They're the traveler wires. Obviously, our neutrals, we got to carry those back. It may be a good idea to put your neutral wires back first, because in this case, we do not use a white wire as a hot, but in some cases, you may have to use a white wire as a hot again. I smell something like strawberries in my office. It's making me hungry. Anyway, so if we have these switches, and you can see these switches that are right here, we're going to kind of follow the path here. If we have our source, this is going to be a hot wire, right? So it's going to have power all the time. It goes into my common. If this switch is flipped down, you'll notice that it's crossing over and it's connecting this brass terminal to the red wire. So this red wire is going to have power flowing through it. Now, that brass terminal is where we got that connected. And if this switch is in the up position, you'll notice that my power is coming across here. This is not allowing power to flow into my light, okay, and complete this circuit. That's why the light bulb is off right now. If I were to flip this switch right here, notice that it moved from that red wire to the black wire and my light turns on. If we follow the path here, we go into the common, we're now no longer going over to here. We're now going into our black traveler wire. It's able to go in through here. That switch is also flipped up. It goes down in your common, and then we can go into our light and get that thing turned on. If I were to flip this switch right here, notice now it's jumping across from your common to your red. The hot power was right here. Okay, so that stops that, and no longer does this light turn on. It basically turns that thing off because it flips it from one line to the other. There's essentially two paths that are flowing into this switch, and one of these two wires is going to be hot, okay, all the time. One of those two wires are going to be hot if you hooked up your commons correctly. You may not necessarily know that, like when it's inside of a wall and all that kind of stuff, you may not know which wires are there, and it doesn't really matter. You know, you don't really need to know that, but just to understand that we have two different paths that are flowing is kind of the critical part. So again, we can flip that switch. If I were to flip, right, that switch back up, we're just going to basically repeat that process. No matter what, these switches, no matter which one I flip, it's going to flip it off or it's going to flip it on. Okay, depending on which one it needs to have power. So I could flip this switch again. I could flip that one up. It's going to go to this black wire, and my power is going to flow. Does that make sense? Yes, no, maybe.
Maybe.
Why do I have a black screen? Okay, maybe. Okay, we're going to do number 6 together. And this is essentially the same thing. But we're going to do number 6 together. I guess I should share my screen with that again. So that way we have that there. And we're going to do our drawings again. Now, there are a couple things that we know that we are going to have, right? Every time from the source, we're going to have our white or neutral wire that is represented by the yellow. We're also going to have a hot wire that's coming in. This does not change from any other diagrams. And then we're going to have our ground wire that's going to be in there as well. Now, if you look at this, we have our single pole double throw switch. This is what we consider a three-way switch. Okay, we have another single pole double throw switch. Both of those things have that C for the common, and they've got their two brass ones. You'll notice on this diagram, it's different than the switch that we had. It doesn't matter. Okay, what matters is that this C is the common. That's going to be the black terminal. Okay, that is on those things. Okay, so make sure that in these diagrams, you look at these different manufacturers are going to place these things in different spots because of how they get them to turn on and off, but that is irrelevant. It doesn't matter. What matters is that black common terminal. Okay. And then we have our light that's down here. So we don't want anything in this box. So that means we're going to be running it through here and then down to there. So what's the first thing that we should do? What do you think?
I would do something that I would know. I would take the greens and connect the greens up first, because I would take it, wire nut it, and then I would connect it to those two, but I would also run it down to the light and run it over to the other box.
So one thing real critical, don't go diagonal here like this.
Yeah, go down.
Yeah.
Right?
Well, we don't want anything in this box right here, right? So what we'll do is we're going to do this right here. We're going to carry every wire is going to be up into here to there, and then we'll just carry our ground down to here, right? So we've got our grounds. We're good with that. I think you guys understand that, from last week. That doesn't change anything on these diagrams. We never want to run diagonal because these things they have, ideally this would be something, like almost these things would be in like a linear kind of space. Sometimes it's not necessarily linear, or it's just kind of like a straight line. But in these cases, for all of these diagrams, just don't run them diagonal. You have to run them up into a box. I can't run one straight to my source here. I've got to go into this box and over. So go in 90 degrees, right? Left or right or up or down with your wires. Okay, so our green wires are done. What do you think we should do next? The order of this doesn't matter, but sometimes it makes life a little bit easier if you do something first versus another thing, if that makes sense. Any guesses? Should we take these neutral wires and should we get them back to my source? Neutral wires are always going to be white, right? So if I do this and I follow that same path, undo that. If I follow that same path, I'm going to come up into this box. Again, I'm not going to go diagonal because I've got to go into this box. I already have this wire. That's going to be Romex there. I'm going to try to make a square as much as I can. It's going to be a wire nut, right? We're going to come down to here. We're going to wire nut that there's no silver terminals on these things, right? No neutral terminals. I'm going to come back up into our source. Our neutral is now carried back. So now we just got to worry about hooking up these terminals on the three-way switch. Okay, and remember, we do not connect more than one terminal to that. So the rule of thumb, one common goes to your source, the other common goes to your load. Now I could theoretically take this wire over here and I could wire nut this thing down to there, and one common would be connected to my load. But that doesn't make sense because this common is so much closer. I can just take one wire and do that I'm just going to connect this common. Oop, I don't want to pass by that one. I'm going to connect this common to my light, and I'm going to take this common and I'm going to connect it into my load there. So our commons are done. There's only one thing that you have to do, and that's to connect these traveler wires. And with these traveler wires, try to just connect them to the same one on the other side. So we're going to do that one there. I've used a green, I've used a black, I've used a white. So my other option, my next option is going to be a red wire. And that red wire is just going to connect to that other one. We now have that same diagram pretty much that we did on that PowerPoint there. That's the same diagram where we're going into our common. It's going to go to one of these two. So the black and the red are always going to have hot power. Okay. And then those are going to have hot power. This switch is going to be just one flip away from either cutting the power or giving it power. It'll be able to go into your light. It's going to be able to return. And this is safe because we have all the ground wires in place to help prevent us from getting an electrical shock. So that is diagram number 6. That's what we got to do. Number 7, this is a three-way switch again. Notice that the positions of these things change. And when you change the positions, okay, it doesn't change where the terminals need to go. It just changes how we kind of wire this thing up a little bit, okay? But the concept is still the same. Commons, one to your load, one to your source, right? Your grounds, obviously, those are the same. Your traveler wires need to connect to one or the other, okay? And then you need to get your neutral wires back. Number 8 is another three-way switch, right? You have two double throw switches that are going to control that light. Okay, it's just a different orientation, except there's nothing in this box. So how we wire that up, same concepts, okay, but how you wire them are going to be slightly different, okay? Just make sure that if you're using a white wire, right, like on the last one, make sure you use that, you mark it accordingly if you're using a white wire as a hot. Reds and blacks, you don't need to mark because those ones are already hot. They're never going to be a neutral wire. They're never going to be a ground wire. The white wire is that one that will bounce back and forth and can kind of change whether it's a neutral or a hot. So on this one, right, 2 3-way switches to control the lights, just like normal. One thing on here, I didn't explain this. We use the term single pole double throw. Okay, what that means is we have a single kind of entry point and it throws it in 2 directions. So when we have this power that comes in here, it's basically going to throw it here. It's going to throw it there. So it's a single pole double throw. That has to do with the amount of switches that are on there. You might see things like on these, scroll up here. On this one, oh, that's not the right one. Single pole, single throw. So that's our single pole, that's our throw, or that's our pole and that's our throw. It doesn't matter. You can flip those ones back and forth because there's not one that matters more than the other. It just kind of depends on where you're coming in and then where you're leaving from that switch. So a single pole, single throw switch is just going to have 2 brass terminals every time. Number 9, I will tell you, okay, you got a single pole, single throw. You got 2 lights there. Don't overcomplicate this one, okay? Number 10 is a single pole double throw. This one light needs to be on and the other off. And then when you flip that switch, this light needs to be off and then that one would need to be on. So it's going to flip flop them. Kind of a funky one, like not really, there's not a lot of instances where you would want one light on and one light off. It's more of just kind of to determine, do you understand how these switches work and how we can kind of control the power. So this one's using a single pole double throw switch, but I'll let you guys think about that and try to diagram that on your own. And then the extra credit one is the 4-way switch here, and that's what we call a double pole double throw. And you'll notice on these ones, there's inputs and there's outputs. We also have a single pole double throw here and a single pole double throw there, and we've got a light. There's not really any direction that, wires, can and can't go. But I will tell you on this one, you're either not going to have wires running in between these boxes or you're not going to have wires running in between these boxes. You can kind of make that choice depending on how you want. Like number 7, like we just did, there's a couple different ways that you can wire this up and still be correct. Okay, there's not just one way, but it's important to kind of understand how these switches work. The 4-way switches, the inputs and the outputs are kind of the key to that. Understanding where your inputs and outputs are at is really important. But that's about as much as I'm going to tell you on that. Because as extra credit, I want you to kind of think a little bit. Okay, I don't want you to use your head.